So here's a practice SAT question. They present us with this equation for h, so h is equal to what you see on the other side of that equal sign. They tell us in the problem statement here that the equation represents the approximate height, so h is the height, it's being measured in meters, of a ball t seconds after it's been launched vertically upward from the ground with an initial velocity of 25 meters per second. So you see I've already got a graph of this being produced, so I literally just type this into my calculator. I did have to make a slight change here, so I had to, on the calculator, of course, have this as y, and then equals, I had to put x's in place of the t's. So h is really taking on the role of y. So this y-axis right here is actually the height of the ball being measured in meters, and then taking on the role of x, we see t's, and t is being measured in seconds, right? So on this axis, we have time, and that's being measured in seconds, right? And so what we can go ahead and kind of think about by looking at this graph is we see that initially the ball is on the ground, right? At time zero, the ball is still 0 meters above the ground. And then as time goes on, the ball starts to rise, 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 and then it's falling, 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 falling until it's back on the ground at this moment right here. So if you look at the question is after approximately how many seconds will the ball hit the ground? Well, based on this graph, you can, in looking at the options, you can kind of recognize what the answer for that's going to be. After how many seconds will the ball hit the ground? It's going to be 5 seconds. You could have had a situation that might have required a little bit more work on your end. You could have maybe tried to use the zero feature on the calculator from out of the calculate menu, if you're familiar with the TI-83 or TI-84, and then found that value a little bit more exactly than just kind of eyeballing it from the graph as we just did. There's another option that I want to just kind of show you right here. If you don't have access to your own calculator, you can still get this answer. If you think about when the ball is on the ground, that's going to be at a height of 0 meters. So if you put 0 in place of h and you try to solve this equation, you wouldn't necessarily want to solve it by isolating t because it is a quadratic equation, so there's going to be more than one solution. So what I went ahead and did here is I solved it by factoring, right? So I had a common factor of t present in both of these terms. I factored a t out of each of these terms, leaving me with a t to the first power after I removed one of the t's from the t squared, and no t on the 25 after I factored the t out of it. So I've got this multiplication problem built now. If I set this factor, just the t equal to 0, that tells me that the height of the ball is 0 meters at time 0. Yeah, that makes sense. The ball hasn't been launched upward yet. But then also when this set of parentheses is equal to 0. So you don't get exactly 5 when you do this calculation. When you isolate the t here, what you end up with is negative 25 divided by negative 4.9, which is really, really close to 5. You could have also used the quadratic formula here, right? This is a quadratic equation. A is negative 4.9, B is positive 25, C is 0, since there's no term without the variable on it present in this equation. So there are a variety of ways you could have gotten this answer. Hopefully what we've discussed here has been helpful to you.